In this nugget, we are going to discuss and demonstrate how you and I can train the NetScaler about reachability to additional networks by using either static routes and or additional subnet IPs. Let's jump in. If you, like me, are very excited and very grateful for things like the internet that connects us all together, it's also possible that we take some things for granted. For example, if we did a quick trace route to 8.8.8.8, you'll notice that there's a lot of coordinated effort in getting my packets all the way up to the Google DNS server. And that's amazing. And that coordinated effort on the internet is done by Border Gateway Protocol, and then at the edges of the internet it's done by interior gateway routing protocols like OSPF. And it's very likely that a lot of small companies, as they connect to the internet, simply default gateway, and the firewall has a default route out to the internet. And then internally, inside of our network, whether it's on our DMZ or on the inside, we may have one or more networks. For example, if this is the 192.168.1.0 network, the NetScaler would need to know about reachability to that network. And if we have one of our interfaces in that same layer 2 broadcast domain, or in that same VLAN, but what if we have a scenario where we have a router connected to one of those networks, and the router is leading off to yet another network? For example, let's say the 10.6.6.0 network. So maybe the router's address here, maybe this is router number 1, and maybe router 1 is directly connected to this 192.168.1 network, and its IP address is .11. Well, maybe the NetScaler doesn't ever need to forward a packet over to 10.6.6. However, if there's resources over here on the 10.6.6 network that the NetScaler needs to communicate with, for example, maybe we have Storefront or other virtual machines or servers that we want the NetScaler to communicate back and forth with, the NetScaler is going to need a route to get to that subnet. And one of the simplest ways of instead of using the default route, which would then attempt to send that packet out in the direction of the internet, which would be rejected by our service providers because we're trying to send a packet to a private RFC 1918 address space, and the service providers are filtering and dropping all that traffic so that it doesn't make it very far into the internet. Now, there is an additional IP address that we can configure on a NetScaler, and it's called a MIP, which stands for a mapped IP address. And I want to tell you a story. It's a little sad, but it's okay. It got better. When I was young, I was very, very small for my age. When I was 16, literally, I weighed 82 pounds and I was 5 feet tall. That was on my first driver's license. And I got pulled over 7 times when I was young just because I looked like I was 12. And let me tell you, it's really tough to get a date when you look like you're 12. Or at least it was for me. So how does that relate to this story? Well, for activities such as sports, if they're picking teams, it's very likely for a sporting activity, I would be picked absolutely last because I was so small. And, I might add, a little awkward. Well, that's what a mapped IP address is all about as well. It's like the last one that's going to be picked. When the NetScaler is communicating with the servers that it's interacting with, by default, it's going to use the subnet IP address as the source address as it communicates with those. And that feature is called use SNIP. So if you see the term USNIP, it's got nothing to do with getting a haircut or anything like that. It's simply saying that we're going to use the subnet IP as our source as we're acting as a TCP proxy doing our load balancing. And that's where the mapped IP address can come into play, is if there are no subnet IPs that are set up. But there is a mapped IP address that's set up. The mapped IP address can be used as a last resort, if you will, as a source address to communicate with servers. And what I would love to do with you in this nugget is I'll show you how to verify our SNPs and create more if we want to. Breadcrumbs that will remind us of where we are in the interface. So if we click on IPs to begin with, here we have the NetScaler IP at .225 on the 192.168.1 network. It even indicates, hey, this is the NetScaler IP, the NSIP. And then we have one subnet IP. And to make this match the topology that we're working with, let me go ahead and add an additional subnet IP that's also on that 192.168.1 network. And so to add an address, we simply click on Add. We'll go ahead and put in the IP address of 192.168.1.226, which is the IP address we want to use for an additional subnet IP address. We'll put in the mask of 24 bits. That's how you spell 24 bits in dotted decimal. The type of IP address is going to be. And from the options here, we have subnet IP, which is what we want. We also have the option for virtual IP, which would be great for a virtual server, and the mapped IP. And again, that mapped IP is like the last resort. If we don't have a subnet IP we can use as a source as we're communicating with a backend server. So we do want this to be a subnet IP, so we'll select that. And then we'll scroll all the way to the bottom. And you'll notice regarding application access controls on this new subnet IP, it has enable management access. If we did or didn't want some of those features, we could just choose them. For example, Telnet. That's terrible. In a production environment, friends don't let friends use Telnet because it is plain text. Also, FTP is not secure. So we'll disable that one as well on this interface. But what I would like to enable is I'd like to enable the graphical user interface. So if you and I wanted to, subnet IPs. We can also sort these based on a column. So if we click on type, it'll sort based on that column. And if we click on type again, it'll sort it in the other order. So we have the NetScaler IP at 225, a subnet IP at 226, and another subnet IP at 10.4.4.225. Also, since we're right here under NetScaler System Network, let's click on Interfaces. Now, on this NetScaler VPX, I've installed it with 4 interfaces. And that first interface is where my license is linked to, based on that MAC address. Also, at the moment, it indicates that I've got a couple of which are currently down. If I wanted to bring be 192.168.1.1. It's a static route. I've got this 127, which in the world of IPv4 represents a loopback address. Virtually every single IPv4 speaking device on the planet believes that 127 anything is itself. So that's nothing that we had to configure. That's showing up free of charge. Then here it shows us that we have a route to the 10.4.4 subnet. And the reason this is here is because we have a subnet IP that begins with 10.4.4 and has a 24-bit mask, and as a result, it assumes that we are directly connected to that subnet. And over here in the flags, the direct is a reflection that we are directly connected. And because we have interfaces in the 192.168.1 subnetwork as well, we are also considered to be directly connected to that network. So if there was a router connected to the 192.168.1 network and its IP address was .11 and it had access to another network like 10.6.6.0, we could go ahead and set up a static route saying, hey, to get to 10.6.6, the next hop is 192.168.1.11. And to create that static route, we just click on Add. We'd put in the network of 10.6.6.0. We'd put in the 24-bit mask, which in dotted decimal is 255.255.255.0. And then we would specify the gateway, the next hop to go ahead and use to reach that remote network. And in our example, that's going to be 192.168.1.11. That's the router's interface on that subnet who knows how to reach, or at least forward, to that remote network. And then we'll go ahead and scroll down and click on Create for our static route. And we also have some options for dynamic routing protocols as well, where we can interact with other routers who are speaking that same protocol to dynamically exchange routes back and forth with other routers. In our case, we're just creating a simple static route, so we'll click on Create. And now, here's our new static route that says to get to 10.6.6, the next hop is 192.168.1.11, and that next hop is reachable to you. In this nugget, we've discussed and demonstrated how we can train the NetScaler about reachability to additional networks using static routes, as well as creating additional IP addresses, such as subnet IPs. I have had a lot of fun in this nugget. I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.